Sequence is nothing but the arrangement of numbers according to a particular definition or particular rule. The sum of n terms of which the first and last term is also known, then it is given by Sn is equal to n by 2 into a plus l. A is the first term and l is the last term. If a and b are any two numbers, then the arithmetic mean between a and b is given by am is equal to a plus b divided by 2. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very easiest and important chapter 8, that is sequence and series. Now let us know regarding the weightage for this. In this chapter you are going to get 11 marks. So the weightage for this chapter is 11 marks. So you may expect one 4 mark question from this, 4 mark 1 question and one 3 marks question and one 2 marks question and then 1 mark 2 questions. So totally 11 marks from this chapter. So that is 4 plus 3 is 7, 7 plus 4 is 11 marks. So totally 11 marks from this chapter. 4 marks 1 question, 3 mark 1 question, 2 marks 1 question and 1 plus 1 mark 2 questions. So totally 4 plus 3 7, 7 plus 2 9, 9 plus 1 plus 1, that is 10 plus 11. So 11 marks is the weightage for this chapter. Now, so today in this session I am going to discuss regarding introduction to sequence and series. What is the definition for the sequence, and then arithmetic and geometric progressions, arithmetic and geometric series, arithmetic and geometric mean. So in this chapter we are going to study the sequence, definition of a sequence and example, arithmetic progressions, geometric progression, and similarly arithmetic mean and geometric mean, and arithmetic and geometric series, arithmetic and geometric mean. So arithmetic mean, arithmetic and geometric series we are going to study in this chapter. Now let us know regarding the definition and the example for a sequence. Now what is a sequence? Sequence is nothing but the arrangement of numbers according to a particular definition or particular rule. The arrangement of numbers according to some rule is called as the sequence. The arrangement of numbers according to some rule is called as the sequence. Say for example, if A1, A2, A3, A4, etc. are the terms of the sequence. So A1, A2, A3, A4 are called as the terms of the sequence, and A1, A2, A3, A4 is called as a sequence. Let us consider for example, the nth term of the sequence is denoted as an. Suppose if an is equal to n into n plus 1, then what are the terms of this sequence? So if you put n is equal to 1, 2, 3, 4, what we will get? If you put n is equal to 1, a1 is equal to 1 into 1 plus 1, that is 1 into 2 is 2. If you put a is equal to 2, 2 into 2 plus 1, that is 2 into 3, that's equal to 6. If you put n is equal to 3, 3 into 3 plus 1, 3 into 4, that's equal to 12. Similarly, if you put n is equal to 4, you will get 4 into 4 plus 1, 4 into 5, that's equal to 20. So what do you say? Therefore this 2, 6, 12, 20, etc. is called a sequence. So here the elements are arranged according to some rule. What is the rule? Each element is of the form n into n plus 1. So therefore this is called a sequence, and the terms 2, 6, 12, 20 are called as the elements of the sequence, and the last term is called the nth term denoted as an. So here an is nothing but n into n plus 1. This is how we are going to define a sequence. Let me define the definition. What is the definition of a sequence? A sequence can be regarded as a function whose domain is the set of all natural numbers. So a sequence is a function. Sequence is regarded as a function whose domain is the set of all natural numbers or some such subset of it of the type 1, 2, 3, etc. k. So and it is denoted as a of n or an. So the sequence is denoted as a of n, or sometimes it is also denoted as a of n, the sequence. So it is the Sequence is recorded as a function whose domain is the set of all natural numbers. Now let us know regarding the second part, series. What is a series? Let A1, A2, A3, etc. An be a given sequence, then A1 plus A2 plus A3, etc. An is called as the series, and it is represented by using as notation sigma. Sigma An, sigma indicates the summation. Sigma An. The sigma An is nothing but, sigma An here is nothing but A1 plus A2 plus A3, etc. up to An terms. Sigma An. Right. Now, let us know regarding what is meant by an arithmetic progression. What is an AP? Arithmetic progression. Now, a sequence A1, A2, A3, etc. An is called the arithmetic progression if An plus 1 is equal to An plus D, where n belongs to a natural number, n belongs to n. Now, in general, the terms of AP is given by A plus D, A plus 2D, etc. A plus n minus 1 into D, where A is the first term and D is the common difference. So, the last term or nth term of an AP is given by L is equal to, or An is equal to A plus n minus 1 into D. So, here the AP is nothing but, if A is the first term and D is the common difference, then the terms of the sequence A plus AD plus A plus 2D, A plus 3D, etc. The last term is A plus n minus 1 into D is called the nth term. The last term is A plus n minus 1. It is denoted as An, or L is equal to A plus n minus 1 into D. The sum of n terms of the AP is given by Sn is equal to n by 2 into 2A plus n minus 1 into D. The sum of n terms of which the first and last term is also known, then it is given by Sn is equal to n by 2 into A plus L. A is the first term and L is the last term. Suppose given two numbers, then how to find the arithmetic mean? The arithmetic mean, the given two numbers A and B, then the arithmetic mean of two numbers A and B is given by capital A is equal to A plus B by 2. Suppose if there are two numbers 3 and 7 are the two numbers, then the arithmetic mean between these two is given by 3 plus 7 by 2, that's equal to 10 by 2 is equal to 5 is the arithmetic mean. So, if A and B are any two numbers, then the arithmetic mean between A and B is given by AM is equal to A plus B divided by 2. This is an example. Let us know regarding what is meant by arithmetic progression, geometric progression. Then I will explain with the examples. Now, a sequence A1, A2, An is called the geometric progression if An plus 1 by An is equal to, for all n is greater than or equal to 1. In general terms, terms of GP are given by A, AR, AR square, AR to the power of n minus 1, where A is the first term and R is the common ratio, n is the number of terms. The nth term of the GP is given by An is equal to AR to the power of n minus 1. So, if A is the first term and R is the common ratio, R is the common ratio. Common ratio is equal to second term divided by its first term. So, any term divided by its previous term will give the common ratio. So, A, AR, AR square, AR cube, etc. AR to the power of n minus 1. AR to the power of n minus 1 is called the nth term of a geometrical progression. Okay. Now, that is AR to the power of n minus 1 is the nth term or general term of a geometrical progression, and the sum of n terms of a geometrical progression is given by Sn is equal to A into 1 minus R power n by 1 minus R, or A into R raised to n minus 1 divided by R minus 1, provided R is less than or equal to or greater than or equal to 1. So, A into 1 minus R to the power of n by 1 minus R raised to n, or A into R raised to n minus 1 divided by R minus 1. So, these are the few formulas which we are going to study to solve the problem. So, these are few formulas. Based on these formulas, we are going to solve the problem. So, these are nothing but the repetition what we have studied in your previous class. Now, geometric mean. What is the geometric mean? So, the geometric mean between two numbers A and B is given by square root of AB, the geometric mean between A and B. So, that is geometric mean. How to find the geometric mean? Suppose if A and B are any two numbers, then the geometric mean between A and B is given by, suppose if C is the geometric mean or G is the geometric mean between A and B. So, G is the geometric mean between A and B, then G by A is equal to B divided by G, cross multiplied, G square is equal to AB, or G is equal to root of AB is the geometrical mean between the two numbers, right? Now, the arithmetic mean between the two numbers is, the arithmetic mean between A and B is A plus B by 2. The geometric mean between these two numbers is root of AB. That's it. Just let us take few problems based on this. Write the first three terms in each of the following sequence defined by the following statements. So what is given? The first one, an is equal to 2n plus 1. Write first 5 terms. So what is to write? We are going to write a1, a2, a3, a4 and a5 are the first 5 terms. Now put n is equal to 1, 2, 3, 4 and 5. If you put n is equal to 1, a1 is equal to 2 into 1 plus 5, that is 2 plus 5 is equal to 7. If you put n is equal to 2, a2 is equal to 2 into 2 plus 5, that is 4 plus 5 is 9. a3, put n is equal to 3, 2 into 3 plus 5, 6 plus 5, that's equal to 11. Put n is equal to 4, 2 into 4 plus 5, 8 plus 5. 8 plus 5 is 13. And the last fifth term, a5 is equal to 2 into 5 plus 5. That's equal to 10 plus 5 is equal to 15. So, therefore, the sequence is, the first 5 terms are, what are the first 5 terms? 7, 9, 11, 13, 15. So, 5 terms of the sequence is 7, 9, 11, 13 and 15 are the 5 terms. Now, suppose if I observe carefully 7, 9, 11, 13, 15. So, this is called is an AP. This is an arithmetic progression. So, here the first term A is equal to 7 and see the common difference. The common difference D is equal to second term minus first term. 9 minus 7 is equal to 2. 11 minus 9, that is also equal to 2. 15 minus 13 is also equal to. So, the common difference is same throughout the sequence. So, such a sequence is called an arithmetic progression, right? Now, then let us take another example. If an is equal to n minus 3 by 4, write the 5 terms. So, put n is equal to 1, 2, 3, 4 and 5. a1 is equal to 1 minus 3 by 4, that's equal to minus 2 by 4 is minus 1 by 2. If you put n is equal to 2, 2 minus 3 by 4, that's equal to minus 1 by 4. If you put n is equal to 3, 3 minus 3 by 4, 0 by 4 is equal to 0. Put n is equal to 4, a4 is equal to 4 minus 3 by 4, that's equal to 1 by 4. Put n is equal to 5, 5 minus 3 by 4, that's equal to 2 by 4 is again 1 by 2. So, therefore, the 5 terms are minus 1 by 2, minus 1 by 4, 0, then plus 1 by 4 and plus 1 by 2. So, the 5 terms of the given sequence is minus 1 by 2, minus 1 by 4, 0, plus 1 by 4 and plus 1 by 2. Hope you followed. Very simple for 1 mark. Right. Now, move on to the next problem. What is the 20th term of the sequence defined by an is equal to n by n plus 1? Now, just we want to find the 20th term. That's it. What is given? an is equal to n divided by n plus 1. Put n is equal to 20. Then you will get a20. That is 20 divided by 20 plus 1. 20 divided by 21. That's it. So, 20 divided by 21 is the 20th term of the given sequence, 20 divided by 21. That's it. Okay. Now, next, move on to the next problem. Write the first 5 terms of each of the following sequence whose nth terms are n into n plus 1. an is equal to n into n, same as that of the previous one. Put n is equal to, how many? 5 terms. N is equal to 1, 2, 3, 4 and 5. So, a1 is equal to 1 into 1 plus 2, 1 into 2, 1 into 3, that's equal to 3. a2, 2 into 2 plus 2, that is 2 into 4, that's equal to 8. A3, put n is equal to 3. 3 into 3 plus 2, that is 3 into 5, that's equal to 15. If you put n is equal to 4, 4 into 4 plus 2, that is 4 into 4 plus 2 is 6. 6 4s are 24. A5, 5 into 5 plus 2, 5 plus 2 is 7, 7 5s are 35. So therefore the sequence A1, comma, A2, A3, A4, A5 is, what are the terms of the sequence? 3, comma, 8, 15, 24 and 35. These are the terms of the sequence. That's it. Now move on to the next problem. So write 5 terms of an is equal to n by n plus 2. Same, put n is equal to 1, 2, 3, 4 and 5. So a1 is equal to 1 by 1 plus 1, that is 1 by 2. A2 is equal to 2 by 2 plus 1, that is 2 by 3. A3 is equal to 3 divided by n is equal to how much? 3 plus 1, that is 3 by 4. We put n is equal to 4. So 4 divided by 4 plus 1, that is 4 by 5. Put n is equal to 5. 5 by 5 plus 1, that is 5 divided by 6. So therefore the terms of the sequence A1, A2, A3, A4 and A5 is 1 by 2, 2 by 3, 3 by 4, 4 by 5 and 5 by 6. So these are the terms of the sequence 1 by 2, 2 by 3, 3 by 4, 4 by 5 and 5 by 6. That's it. Okay. Now move on to the next problem. Next, if an is equal to minus 1 to the power of n minus 1 into 5 to the power of n plus 1. Now first write 5 terms. So same, put n is equal to 1, 2, 3, 4 and 5. A1 is equal to minus 1 to the power of 1 minus 1 into 5 to the power of 1 plus 1. So minus 1 to the power of 1 minus 1 is 0 into 5 to the power of 2. See, minus 1 to the power of 0, any number, you know a to the power of 0 is always equal to 1. 1 into 5 square is 25. The first term is 25. Okay. Now just put n is equal to 2. You put n is equal to 2, minus 1 whole to the power of 2 minus 1 into 5 to the power of 2 plus 1. That is minus 1 whole to the power of 2 minus 1 is 1 into 5 to the power of 2 plus 1 is 3. Minus 1 to the power of 1 is minus 1. Minus 1 into 5 cube. 5 5s are 25 into 5 is 125. So minus 1 into 125 is minus 125. Okay. Now put n is equal to 3. If you put n is equal to 3, minus 1 whole to the power of 3 minus 1 into 5 to the power of 3 plus 1. That is minus 1 whole square into 5 to the power of 3 plus 1 is 4. Minus 1 whole square means minus into minus plus 1 into 1 is 1 into 5 to the power of 4. 5 into 5 into 5 into 5. 5 5s are 25. 25 into 5 is 125. 125 into 5 is 625. So 1 into 625 is 625. Now put n is equal to 4. A4 is equal to minus 1 to the power of n is 4 minus 1 into 5 to the power of 4 plus 1. So minus 1 whole cube into 5 to the power of 4 plus 1 is 5. So minus 1 whole cube is minus 1 into minus 1 into minus is minus into minus plus into minus minus 1 you will get minus 1 into 5 to the power of 5 is 625 into 5. So 625 into 5 is 3125. This is 3125. So minus 1 into 3125 is 3125 along with negative sign. Minus 3125. Now the last term A5, put n is equal to 5. Minus 1 to the power of 5 minus 1 into 5 to the power of 5 plus 1. Minus 1 raised to 4 into 5 to the power of 5 plus 1 is 6. If you multiply minus 1 4 times, you will get plus. So 5 to the power of 6 means 3125 into 5. What is that equal to? 15, 625. 15, 60, 625. So 1 into 15, 625 is 15, 625. So therefore the terms of the sequence are, so this is A1, A2, A3, A4 and A5. That's it. These are the 5 terms of the given statement. An is equal to minus 1 to the power of n minus 1 into 5 to the power of n plus 1. Now move on to the next problem. Find the indicator terms in each of the following sequence whose nth terms are given. So just find the indicator term is find A17 and A24 where the nth term is given. What is given? An is equal to 4n minus 3. What is to find? A17. Put n is equal to 17 first. Then you will get A17 is equal to 4 into 17 minus 3. 4 into 17 minus 3. Now, what is this equal to? 17 fours are 68 minus 3. 68 minus 3 is 65. So, the 17th term is 65. That's it. Say put n is equal to 17. 4 into 17 minus 3. 17 fours are 68 minus 3 is 65. Now, second one. A25. Put n is equal to 24. A24. Put n is equal to 24. A24 is equal to 4 into 24 minus 3. So, what is this equal to? 24 into 4 is 96. 4 fours are 16. 4 to 8 plus 1 is 96 minus 3. 96 minus 3 is 93. So, therefore, the 24th term is 93. The 17th term is 65 and the 24th term is 93. So, these are the indicated terms in the given problem. Okay. Now, move on to the next problem. So, what is given? An is equal to n square by 2 to the power of n. Find a to the power of a7. Now, to find a7, put n is equal to 7. That's all. Put n is equal to 7 in an is equal to n square divided by 2 to the power of n. So, that is 7 square divided by 2 to the power of 7. What is 7 square? 7 square, 7 into 7. 7 sevens are 49 divided by 2 power 7. So, 2 power 7. So, 7 square means 7 into 7, that is 49. 2 to the power of 7 means 2 into 2 into 2, 7 times. 1, 2, 3, 4, 5, 6, 7. 2 2s are 4, 4 2s are 16, 16 2s are 32 into 2 is 64. 64 into 2 is 128. Right. So, this is 128. So, 49 divided by 128. If it is possible to divide it. Otherwise, keep it as it is. Now, move on to the next problem. Write the first 5 terms of the sequence and obtain the corresponding series. Now, very simple. So, what is to find? A1 is given 3. An is equal to 3an minus 1 plus 2 for all n is greater than 1. Now, A1 is given. What is given? A1 is equal to 3. Now, just find out when n is greater than 1. N is greater than 1 means put n is equal to 2, 3, 4, etc. Right. Now, if n is equal to 2, A2 is equal to 3 into A2 minus 1 plus 2. That is nothing but A2 minus 1 is 1 plus 2. Since we know what is A1, A1 is equal to 3 plus 2. So, that is 3 3s are 9 plus 2. 9 plus 2 is 11. Similarly, put n is equal to 3. Then what you will get? A3 is equal to 3 into A3 minus 1 plus 2. That is 3A2 plus 2. 3 into A2. A2 is 11 plus 2. 11 3s are 33 plus 2. That's equal to 35. So, if you put n is equal to 4. If you put n is equal to 4, then you will get the fourth term. A4 is equal to 3 into A4 minus 1 plus 2. That is 3A3 plus 2. 3 into what is A3? 35 plus 2. So, multiply 35 into 3. 5 3s are 15. 1 3 3s are 9 plus 1 is 10. 105 plus 2, this is 107. So, therefore, the series is, what is the first term? First term is 3, A1 is 3, A2 is 11 and A3 is 35, A4 is 107, etc. So, this is the required series, right? An example for recurrence relation. Now, 3 3, 11, 35 and 107. That's it. Okay. Now again, what is to 5? Write 5 terms. So put n is equal to one more term. So if you put n is equal to 5, what we will get? A5 is equal, if you observe carefully, we are going to get in the form 3 times A. So if it is 3 means we are getting A2. If it is 4 means we are getting A3. If it is 5 means we are going to get A4 plus 2. 3 into what is A4? 107 plus 2. So if you multiply this 3 into 107 plus 2, this is 7 3s are 21, 1 and 2, 3 1s are 3. 321 plus 2, that is 323. Okay, so the next term is 323. So these are the 5 terms of the sequence. So therefore, write the first 5 terms of the sequence and obtain the corresponding series. Therefore, the series is add this 3 plus 11 plus 35 plus 107 plus 323. That's all. This is the required series. That's it. Okay. Now let us take next problem. Same type problem. A1 is given. What is AN? A1 is equal to minus 1. AN is equal to AN minus 1 divided by 1, where n is greater than or equal to 1. So put n is equal to 2. A2 is equal to A2 minus 1 divided by 2. That is A1 by 2. What is A1? A1 is minus 1. Minus 1 by 2. Put n is equal to 3. So that is A3 minus 1 by 3. A3 minus 1 is A2 divided by 3. What is A2? A2 is equal to minus 1 by 2 divided by 3. This is minus 1 by 6. So A4, I'll write 4. A4 is equal to, A4 is nothing but A4 minus 1 by 4. That is A3 by 4. What is A3? A3 is minus 1 by 6 by 4. So this is equal to minus 6 4s are 24. And the fifth term A5 is equal to A5 minus 1 by 5. That is nothing but A4 by 5. What is A4? Minus 1 by 24 divided by 5. That's equal to minus 1 over 24 into 5. That is 120. Therefore, the terms of the series, 5 terms are minus 1, minus 1 by 2, minus 1 by 6, minus 1 by 24 and minus 1 by 120. These are the 5 terms, right? Therefore, the series is minus 1 plus minus 1 by 2 plus minus 1 by 6 plus minus 1 by 24 plus minus 1 by 120 plus etc. This is the required series for the given problem. That's it. Hope you followed. So these are very simple problems for 1 or 2 marks. That's it. Right. So hope you followed. Now, so that's all regarding today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.